Okay, so now that we've turned in our projects, we're going to go on to Chapter 9. So Chapter 9 is all about quadratic functions and their properties. So if we look back from Chapter 8, we know that a polynomial with a degree of 2 is called a quadratic polynomial. Okay, a quadratic polynomial and a quadratic function is a type of nonlinear function that models certain situations where the rate of change is not constant. So just our linear functions are always constant. They have the same rate of change. Quadratic functions aren't constant at all. So a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where our a cannot equal 0, okay? So we can't have this a right here equal 0 because then that would mean that we wouldn't have that x squared, which wouldn't make it a quadratic, okay? So the standard form is just that f of x equals ax squared plus bx plus c, okay? The quadratic parent function, we talked about this last semester, is just the simplest form of any function. So the simplest form of a quadratic function is just f of x equals x squared. So f of x equals x squared, okay? A parabola, it is the graph of a quadratic function. So it's a graph of a quadratic function. It is U-shaped. And it opens either up or down. Okay, so we have a parabola right here. This one's opened up, okay? The axis of symmetry. Symmetry means that it's the same on both sides. It looks very similar. So our axis of symmetry is the line that divides a parabola in half. Okay, in our vertex, last thing for this page, our vertex is the highest or lowest point of our parabola. So it's the highest or lowest point of a parabola. Okay, along with that, our axis of symmetry intersects at the vertex. So on this parabola right here, our axis of symmetry would just be this line down the middle, and our vertex would actually be the point on that line that happens to be the lowest point of our parabola. Okay, moving on to the next page. So our minimum is going to be our y coordinate of the vertex of a parabola that opens upward. That opens upward. Okay, so our minimum is just going to be like our valley, our lowest point of our valley, okay? And a maximum is going to be our y coordinate of the vertex of a parabola that opens downward. Okay, So if we have a parabola that opens downward, it's going to have a maximum, and that's going to be at the top of the mountain, okay? So on our first problem right here, it wants us to tell what our coordinates of our vertex is of each graph and whether it's a minimum or maximum. So when we're looking at a parabola right here, okay, we know that this parabola opens downward, so we want to find the highest point of each parabola. So since this parabola opens downward, we're going to hit it at the highest point and in the middle, so that if I were to cut it in half and flip it over like a book, like a page in a book, it should match up with each other. So our highest point right here, if we start at this, if our x coordinate is 0, our y coordinate is going to be 3. Okay, so that's going to be our vertex. And since it's the top of the mountain, just like we had up here, since it's the top of the mountain, that means that's going to be our maximum. Okay, moving right on to B, we want to find the lowest point of this one because our parabola opens up. So our lowest point would be right in the middle of our parabola. So we need to find our x coordinate. Our x coordinate is going to be 1, and our y coordinate is going to be -1. Okay, so that's going to be our vertex. Okay, and since it's at the bottom of a valley, that means that it's going to be a minimum. Okay, so I want you to go on to the got it problem, work through it, pause the video if you want to, then come back and check your answer. So for this one, it opens upward, so we're going to find our minimum. So our point, our x coordinate of our point is going to be -2, and our y coordinate of our point is going to be -3. So that's our vertex, and because it's at the bottom of the valley, that's going to be our minimum. Okay, moving on to the next page. We can use the fact that our parabola is symmetric to be able to graph it quickly. Okay, so symmetric means that if I have it on one side of the parabola, I also have it at that same point on the other side of the parabola. So when we're working through these, we are going to find, for this one, our x values are going to be 0, 3, and 6. The reason I picked these is because all of these numbers are divisible by 3, so it'll give us nice even numbers. Okay, so if I plug in 0 for my x coordinate, if I do 1/3 times 0, that's just going to give me 0. So our point would be 0, 0. So I'm going to graph that point on our graph. My next coordinate, or my next x coordinate that I'm going to put in is 3. So I'm going to have 1/3 times 3 squared. 3 squared is going to give us 9. If we do 1/3 times 9, that's just like 9 divided by 3. That's going to give us 3. So our next coordinate is going to be 3, 3. So I'm going to go over 3 and up 3 and graph that point. Because a parabola is symmetric, we can do the opposite as well. So we can go over to the left 3 and up 3, and that's going to be our other side of our parabola. Okay? And our last one, I'm going to put in 6 for our x value. Okay, and when I work that out, that's going to give me 12. So our point is going to be 6, 12. Okay, so I'm going to go over all the way to 6 and up to 12. We need to go a couple spaces above. Okay, so I'm going to estimate 12 is going to be right there. And then we're going to go to our -6 and up to 12. Okay, so when I graph this, it's going to look like a U shape. Okay, it's just going to keep going up. Okay, so one thing we want to know is what our domain and what our range is. So if we remember from last semester, our domain is all of our x values and our range is all of our y values. So for a parabola, our domain will always be all real numbers. So our domain is going to be all real numbers, because that U is just going to keep expanding as it goes further, okay? And our range is all of our Y values. So if we said that our minimum is going to be 0, that means that our Y is always going to be greater than or equal to 0, okay? If you want to go ahead and work on the got it problem, you may. You can pause the video and then come back to check your answer. For this graph, I'm just going to put in 0, 1, and 2, okay? So for our first one, if I put in 0 to our x squared, that's just going to give me 0 again. So our vertex is going to be 0, 0. Graph that on there. Our next one, we have negative 3 times 1 squared, which is just going to give us negative 3. So our next point is going to be 1, negative 3. So I'm going to go over 1 and down 3, graph it. And I'm going to go to the other side 1 and down 3 and graph it. Okay? And our last one, we have negative 3 times 2 squared, which is going to give us negative 12. So our last point is going to be 2, negative 12. So I'm going to go over 2 and down 12, should be right about here. And I'm going to go to negative 2 and down 12, should be somewhere right here. So we're going to graph that. Should look like a skinnier U, okay? So our domain for all parabolas will be all real numbers, and our range. Since this parabola is pointed down, that means we're going to have a maximum, which means that y is going to be less than or equal to 0, okay? Because we don't have any y values that are going above that vertex. We only have y values that are going to be below that vertex. Okay, so the coefficient of the x squared term in a quadratic function affects the width of the parabola and which way it opens. So the width is determined by whether you have a whole number or a fraction, and whether it's opened up or down depends on whether you have a negative or a positive in front of that x squared term. So when we have a negative in front of our x squared term, that means that the parabola is faced down or opens down. The parabola opens down, okay? And when we have a fraction, it makes the parabola wider. Okay, so when we are going through the order of whether it's widest to narrowest, what we're looking for is whether it has a fraction or not. So when it has a fraction, that means it's going to be the widest it has. So for our first one, we're going to have 1/4 x squared, because that is going to be our widest function, okay? Then we're going to look to see what our next smallest coefficient is. So our coefficient on our x squared term is just 1, therefore that is going to be our next widest. And our coefficient on our first one is a -4, which is going to be our biggest coefficient, not necessarily a positive coefficient, but just the coefficient itself makes it narrower, okay? So go ahead and work on your got it problem. Come back and check the answer.